Hi, so we are going to do a few examples of factoring a trinomial where the a value does not equal 1. So remember, the a value is the coefficient with the squared term. So in this example I have here on the page, our variable is k, but if we notice here, our a value is 5. Now, we will always check to see if it is possible to factor out or common factor out that value, but in this case we can't. We can't divide 13 by 5 and we can't divide 6 by 5. So this is how we are going to do it, and the method we're going to use is called the seesaw method. So what we want to find two numbers that multiply 2. It's going to be the value with the squared term multiplied to the value on its own. So we want two numbers that multiply to positive 30, 5 times 6, and that add to positive 13. Now what we're going to do now is make a factor tree for the number that we need to multiply to. So I'm going to write 30 here, draw a little line, and I'm going to start at 1 and try and determine all the factor pairs. So 1 times what gives me 30? Well, 1 times 30. 2 times 15 gives me 30. 3 times 10 gives me 30. 4 doesn't work. 5 times 6 gives me 30, and the next number I would try would be 6, but since it's already on the list, I know that my list is done. Okay, so now what we have to do is we have to find the pair of numbers that will add to a positive 13. So if I look at my numbers here, well, I see that a 3 and a 10 will multiply to, or will add to 13 and still multiply to positive 30. Since it needs to multiply to a positive number, I know that both my numbers have to be positive or both of them have to be negative. But since I need to add to positive 13, the signs that I want are positive 10 and positive 3. All right, now in order to use the seesaw method, once we have those numbers, how we're going to set this up is we're going to open two brackets. Okay, and this first term, we're going to put into each bracket, but just the 5k. We're not going to put 5k squared. Okay, and then we're going to divide it by that coefficient, so divide it by 5. So this is like our little skeleton, all right? So once we have our skeleton made, what we're going to do is we're going to take those two numbers we just found and put them into each bracket. So we have 5k plus 3, and we have 5k plus 10. All right, this is not our answer. We need to factor out something out of one or both of those brackets in order for this to be correct. We also don't want to be dividing by 5, but we need it there so that it will cancel with what we common factor out. So what we're going to do is we're going to look at both of our brackets. So we have 5k plus 3 and 5k plus 10. And can we common factor anything out of either of those two brackets? Well, yes. In the second bracket here, we have a 5k and a 10, so we can divide 5 out of that bracket. All right, so the first one we can't do anything with, so we will just leave it as it is, 5k plus 3. And when we common factor that, we are going to common factor a 5 out, so the 5 just gets brought out. Now they're all being multiplied, so I don't need to see any signs, but what I'm left with is a k plus 2, and I still have it over 5. Now, why we did that is so that we could cancel this 5 in the top, this 5 in the bottom, and my final answer now is what I have left. So this is 5k plus 3 and k plus 2. Now, what we can do to check to make sure we are correct is we can take that answer that we have and we are going to FOIL it to make sure it gives us what we started with. So I don't know why that got wider. Let's see. Okay, so when we do our check, we're just going to FOIL what we have. We have, our answer was 5k plus 3, k plus 2, and we're going to FOIL this. We do first, outer, inner, last, distribute that and collect like terms. So here we have 5k squared plus 2, oops, sorry, plus, oh, deleted, so 5k squared plus 10k plus 3k plus 6, and we're going to add our like terms, so we have 5k squared plus 13k plus 6. Now we go back and check and make sure that is what we started with. So when we go up, yes it is. So I know that when I factored, this answer here is correct. All right, so we are going to go on to another example. We have this one here, and we're going to do the same thing. So we have 5k squared minus 26 plus 24. Again, we want our numbers to be, or we want to find two numbers that multiply to 5 times 24, which is 120. So we want two numbers that multiply to 120, a positive 120, and add to negative 26. All right, so from here, we're going to make our factor tree for 120. Again, it seems like a big number, but it really isn't. So we'll start at 1 and work our way up. 1 times 120 gives us 120. 2 times 60 gives us 120. 3 times 40 gives us 120. 4 times 30 gives us 120. 5 times 24 gives us 120. 6 times 20 gives us 120. 7 doesn't work. 8, I don't think so. 8. Oh, yep, 8 and 15. 9 does not work. 10 does work, so 10 and 12. The next number we would check is 11 and then 12, but it's on our list. So this is our list. Okay, it looks like a long list, but it's not that bad. Now, it's going to multiply to a positive 120 and add to a negative 26. So we either need two numbers that are going to be positive or two numbers that are going to be negative. And since it adds to a negative number, we're going to look for two numbers that are going to be negative. So going back to our factor pairs, which pair will somehow add to give us negative 26? Well, I notice these ones, okay, the 6 and the 20. And if I stick a negative on each, then when I multiply a negative 6, negative 20, I get positive 120. And if I add them, I get a negative 26. All right, so what we're going to do, we're going to do the same as before. Open up our two brackets, put a 5k in each. Okay, and oops, divide by 5. Okay, so it's just this a value that we're going to divide by. Now we're going to take our numbers, we're going to put 1 in each, 5k minus 20, 5k minus 6, and we have to common factor. So I notice in this first bracket here, we can common factor out of 5. So we have 5 there. We're left with k minus 4. And then we have a 5k minus 6. We can't common factor anything out there, so we divide by 5 again. And the whole point of doing the seesaw method when we have this is we need to cancel these. Okay, this will always happen. So what we're left with is k minus 4 and 5k minus 6. All right. Again, we can go back and check, but we're not going to do this right now. Okay, so often we will see it where we can common factor out the value that's in the denominator, but in some cases we'll have to common factor out of each, and then we'll have to cancel that way. So it may be a little bit different. So here we're going to do this different example. Here we want two numbers that multiply to positive 28, okay, which is just 4 times 7. And add to positive 16. Then we'll make our factor tree for the positive 28. We'll write down all our factor pairs. Start with 1. 1 times 28 gives me 28. 2 times 14 gives me 28. 3 doesn't work. We have 4 times 7 gives me 28. 5 doesn't work. 6 doesn't work. And 7's on my list, so we're done. Now, we have to ask ourselves, which pair of numbers can we add so we get 16? Well, right away I see that it's 2 and 14. right, so we're going to set it up the same way. We have a 4x in each bracket. Then, oops, can you erase that? Then we will divide by 4. Put one of those numbers in each, so we have 4x plus 2, 4x plus 14. And now we have to common factor. So from this first bracket, we can take out a 2. So we have 2, and then we're left with 2x plus 1. And then in the second one, we can take out some. We can also take out a 2, so we're left with 2x plus 7. And divide by 4. Now, in all of our other examples, we could just cancel 1. Sorry, my dog was crying at the door, so I forget where I left off. But in the other examples, we would common factor out the number that we needed to cancel. So in this case, that isn't happening. So what is different is that instead of seeing a 4 that we're going to cancel, what we actually have are these two 2's that when we multiply them, we get the 4. Okay? Now, those will cancel. 2 times 2 is a 4 in the numerator, and that will cancel with a 4 in the denominator. And then what we're left with are just those 2 brackets. 2x plus 1, 2x plus 7. All right, so it's slightly different in this case, but you just need to know that you have to common factor from both. Always try and common factor from both to see what you get. All right, well, I hope that explains some of it. And if you have any more questions, you can see me in class.